This is lesson 1 in the series. We're going to start chapter 5, applying quadratic models. In general, in this chapter, we're going to technically look at some, let's say, shapes or structures that we'll find all over the place and try to model them using a quadratic relation. But to do so, we're going to learn some equations and relations first. So let's go to EDSB. Those are the learning goals. Number 1, we're going to determine the vertical stretches slash compressions, or compressions of this relation. Now this is y equals x squared. Y equals x squared is the basic quadratic relation. It's the primitive one, let's say. In math, we call it the parent function or the parent relation. Second, we're going to identify horizontal slash vertical translations. Now, I don't think this is a new word to you. I think you know what translations are. But anyway, we're going to talk about them in details. Again, of the parent function or the parent relation. Then we're going to identify reflection. Again, I don't think this is a new word. So, of y equals x squared. Then we're going to learn a new form of the quadratic relations. It's the vertex form. And then try to model some shapes using that vertex form. So far, we have learned two forms about quadratic relations. Standard form, ax squared plus bx plus c. It is good to tell us the direction of the opening. So if a is greater than 0, that's a positive number. Then it opens up. A is less than 0, that's a negative number. It opens down. C, however, tells us about the y-intercept. So just by looking at the equation, I know those details. Let's say that's an example. Y equals negative 3x squared minus 4x plus 6. A is negative 3, so it's opening downward. Opening downward, hence it has a maximum value. And I'm sure that the y-intercept is 0, 6, even without graphing it. Now the second form would be the factored form. We've also learned that before. A into x minus r, x minus s. R and s are the zeros. Zeros, which means that those are the values for x, which make each bracket 0. So r minus r would be 0, s minus s would be 0. In other words, those are also the x-intercepts. A simple example here, a is 2, opening upward. X minus 4 is the first, second is x plus 3. So what makes this bracket 0? 4 makes it 0, so 4 minus 4 is 0. So that's my first x-intercept. Negative 3 makes this 0. Or simply solve the equation equals to 0. We've done that a lot. Now, how do we move from the standard form to the factored form? We have the various factoring techniques that we've learned. Vice versa, when we go to from the factored form to the standard form, we can expand using the FOIL method. Now, let's graph a quadratic relation. I have one graph for you here. Y equals x squared minus 3x plus 2. I insisted to write 1 here to show you that the value of a is 1, and the graph is going to open upward. It's going to have a minimum point, and that's the vertex. 2 x-intercepts, or 2 zeros in this case. So even if I deleted 1, nothing will change. X squared minus 3x plus 2, that's still going to be my equation. Now, by looking at the zeros, 1, so r is 1 and s is 2. So I can write it probably in factored form now. Y equals x minus 1. That's the first. The second bracket would be x minus 2. If you see here, the new graph, the blue one, just coincided with the original one. Because technically, they are like just two faces for, or two sides for the same coin. So two shapes or two like equations for the same graph. Now, the new thing here, we're going to learn the third form. That would be the vertex form. And this form would be, from its name, just by looking at that form, we can know the vertex. But we're going to get to that like in a bit. Now, one more thing. For example, I know any quadratic relation has an axis of symmetry, which is a line that lies just halfway between all the points of the graph. Those are symmetrical parabolas. So how do we find the axis of symmetry again? That's the first x-intercept. That's the second. So the distance between them just divided by half. Find the midpoint. So it is going to be like 1 plus 2. That is 3. Divide that by 2, you get 1.5. That's the axis of symmetry. After the axis of symmetry, let me first just graph it. X equals 1.5. That's the line, x equals 1.5. It's just a line that is in the middle between any 2 points that are on the same level. So let's say at the level x, at the level y equals 2, at this level here, this line just divides those two, like divides the parabola into two similar halves. So the distance from here to here should be the same as the distance from this point to that point. That is why we call it the axis of symmetry. And now this happens like at every level. So at 1, at 1.1, 1.2, 1, just at all the points. And I know that this line should pass through the vertex. Now, how to get the x or the h or the line of symmetry? We just find the midpoint between the zeros. Then if you want to find the k, which is the minimum value here, we just go and plug in this 1.5 into one of the equations. Just put x equal 1.5 here or here, then the y value should be negative 0.25. That's my vertex. And technically that is like everything we've learned so far about quadratic relations: how to find the vertex, how to find the zeros, how to write the standard form, how to write it in factored form. Just one more thing, if you look here, that's a standard form. I know a equals 1, then I can use the sum and product. So two numbers whose product is 2, 1 and 2 technically. So 1 and 2. 1 times 2 is 2. Negative 1 times negative 2 is 2. Negative 1, negative 2 gives me negative 3. So the sum is 2 and the product is 2 and the sum is negative 3. That is how we could factor from here to here. Just refreshing your memory. Our lesson tomorrow would be about how to find a new form called the vertex form. Now, I had downloaded some documents here, if you see them on Etsy. We will work through them. I'm not gonna just throw in the surprise here. We're gonna deduce that form, as I said here. I'm not gonna teach you that form. You will deduce it by working through the worksheets that I've designed here. I will lead you through them while we meet on Hangouts on Monday. Our meeting on Monday is going to be at 8:40 a.m. just to test how things would go. Regularly, so for the next days, we're going to start our lesson or class at 9 a.m. from 9 till 11. But just to test ourselves, test or troubleshoot or do a, let's say, a dummy session. So we will start at 8:40, which is our normal class time. Um, Again, one more thing you need to do is once you open those attachments, you're going to be solving them, solving the equations or solving the problems. You have two options: either print them out and then solve on the paper, or just solve on a blank sheet of paper. Now the problem is, what, how would you just upload that, or how would you show me that solution? Because as we do in class, like, you would solve, do the work, and I would be checking and just giving you my feedback. So we have two options here. You could either just take a photo of that and just send it to me on Etsby. The other option would be, I think that would be faster. Again, like, just open, like, or set up your Google Drive, and again, take just a photo using your mobile phone and immediately upload it to Google Drive, which it takes like maybe 2 seconds to upload to Google Drive, and then give me access to that Google Drive, so I would be able to look at that and have, let's say, a look at your work, and then I would give you feedback. I'm going to be sending also an email including all those details, and I'm looking forward to see you on Monday. Thank you.